Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 15, Lens Library. The newly focused parabolic reflector dish is sending all of its collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by a wall of large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility. The next smaller sign says Danger! Personal protective equipment required beyond this point. As you step aside, you immediately are greeted by a somewhat panicked reindeer wearing goggles and loose-fitting hard hat. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fits, and then further into the facility. At one point you pass a button with a faint snout mark and a label Push for Help. No wonder you were loaded into a trebuchet so quickly. As you pass through the final set of doors surrounded with even more warning signs into what must be a room that collects all the light from the outside, as you admire the large assortment of lenses available to further focus the light. The reindeer brings you a book titled Initiation Manual. Hello, the book carefully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the Holiday ASCII string helper algorithm Appendix A. You turn to Appendix A. The reindeer leans closer with interest. The hash algorithm is a way of turn a string of characters into a single number, range 0 to 255. Run the hash algorithm on a string, start with the current value of 0, then for each character in the string, starting from the beginning. Determine the ASCII code in the current character of the string, increase the current value with the ASCII code you just determined, set the current value to itself multiplied by 17, set the current value to the remainder of the dividing itself by 255. After following these steps for each character in the string in order, the current value of the output of the hash algorithm. So we need to write the hash algorithm and then the initiation sequence, your puzzle input, is a comma-separated list of steps to start the lava production facility. Ignore the new line characters when parsing the initiation sequence. To verify your hash algorithm is working, the book offers the sum of the results of the running the hash algorithm on each step in the initiation sequence, for example. Okay. So let's switch over to my code here. Let's do the first hash just as a warm-up. So we will take the word hash and then hash with large characters, and we want it to return an integer. I don't think it will be that large. Or we know it will not be large because it's using the reminder. So the first character, first we need to do a for loop of the string C hash. Or no, we can actually do just a normal for loop. Like that. And then after that, we can look at the hash. I think we can get the code point at that index. Let's do a system out on that. Because I think that will give us the missing statement. Return 0. Yeah, so we got 72, 65, 83, 72. So in this case, we will probably be able to do int hash equals to 0, hash val, and then we do hash val, add that, and then hash val, the reminder of 256, and then hash val. So if we run that, we get 36. Was that the right value for the first one? 52 is the... Oh, we will need to multiply as well. Hash val multiply with 17. And then we get 52. Yes. So now I only need to take this line and split it with a comma for each string s. Like that. And we have a value here, so we will take val plus equal to hash s. And then we will val print that out. So let's see what that gets us. 1320. Yeah, so that's correct. And if we switch it over to the real function here. Yeah, you get a gold star. I get a gold star. Everybody gets a gold star. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. So let's go into part 2. You convince the reindeer to bring you the page that confirms your hash algorithm is working. The book goes to describe a series of 256 boxes numbered from 0 to 255. The boxes are arranged in a line starting from the point where the light enters the facility. The boxes has holes to allow the light to pass through the box to the next, all the way down the line. Inside each box there are several lens slots that will keep a lens correctly positioned to focus the light passing through the box. The side of each box has a panel that opens to allow you to insert and remove lenses as necessary. Along the wall running parallel with the boxes is a large library containing lenses organized by focal length, ranging from 1 to 9. The reindeer also brings you a small handheld labeled printer. The book goes on to explain how to perform each step in the initialization sequence, a process called a holiday ASCII string helper manual. The arrangement procedure, or hash map for short. Each step begins with a sequence of letters that indicate the label of the lens, on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. The label will be immediately followed by a character that indicates the operation to perform. So either equal signs or dash. If the operation character is a dash, go to the relevant box and remove the lens with a given label if it's presented in the box. Then move to any remaining lenses as far forward in the box as you can go without changing their order. Filling any space made by removing an indicated lens. If no lens is in the box that has the given label, nothing happens. Okay? So go to the relevant box and remove the lens with the given label if it's present in the box. Then move any remaining lenses as far forward in the box as they can go without changing their order. Okay. Filling any space that are made by removing the indicated lens. If no lens in the box has the given label, nothing happens. If the operation character is an equal sign, it will be followed by the number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given in the beginning of the step, so it can find it later. There are two situations. If there is already a lens in the box with the same label, replace the old lens with a new lens. Remove the old lens and put the new lens in its place, not moving any other lenses in the box. If there is not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Do not move any of the other lenses when you do this. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. So the second part, it's a hash map with a bunch of lists in them. So I'm gonna create that. We have a string, or we can take an integer with a list of strings. Map name doesn't really matter. So now let's see. Remove a bunch of these so we have a little bit more space here. We pretty much want to if the string contains an equal sign, else, and then we will take the string and split it by the equal sign. So string, just an array there. So that's what we want to do first. And then we want to hash the first part, 0. And then we want to insert in that place with the full string. And then down here, we pretty much want to do the same thing and then remove that 0. So now we just need to implement this map. We put up here and say that it's private static map. And then we want to for int I 256 I plus plus and map put I new array list like that. So now we have a map full of array lists. So what we want to do here is that we want to take this map, get the first hash value there. So this is a list of string, call that box, and the box we go through each string in the box. And we can actually put in the first part here as well. String label. So in here we go through the box, and if S starts with label plus an equal sign, no, we do a for loop with index box length size plus plus, because we want to be able to replace it. So did we replace it in place, or if there is already a lens in the box with the same label, replace the old lens with a new lens. Remove the old lens and put the new lens in its place, not moving any other lenses in the box. Yes, so we actually need to go through the box, get I. If that starts with this, then we will box put or set I value like that, and then we can break. And we need a boolean found true. If not found, we will just box add value. So now we have that little part, and removing is pretty much this again. The only difference is that we will remove it. Remove I. Like that. So let's go to our example again. and see what we get. Yeah. Label. Use better names. So we have the correct box status there. Calculate boxes, map, and then val equals to that. And we get that. Return val, long val. There we go. Now we have the value. Now we just need to calculate this box. And this is the correct way of calculating it. To do map, entry, integer, list of strings, entry, map, entry set. There we go. Stop that. So first off, we create a new value here. Long inter new value. And that is equal to the entry get key. So we start there. We get the box, and we will add one to it. Next up, we will box value. Box value. And then we will take the for loop over the strings. Entry. We have a list here. List. Entry get value. So the list size I plus. So now we have the index of all the parts of the list. So in this case, we will get the first one here. And it's the position, first slot, second slot, and so on. So list get I. This is the string. And this string we need to split with a question mark. So now we have pretty much all parts. Operation, second part, integer parse int. So that should be val plus equal to that times I plus 1 times box value plus 1. Okay, box value we have already added to. That's correct. Like that. So if we run this full here, we get 145, which is the right value. And if we switch over to run the full example here, we get that value. And if we put that into the answer, yes, you get a gold star. I get a gold star. Everybody gets a gold star. So let's switch over here and see what we did. First off, we created up this map. It's a static map with strings in it. So a list of string and an integer position. And we will create up all the boxes so we have them. No exceptions. And then we need to go through all the strings and look at the different parts of the string. So we have the equal sign, which means that we should add a value to the list. So we split it up to an array here. The first label part, we will hash that and then also give the label, and then we will send in the full thing into insert. And we will do the same with the remove. The only thing, the difference is we have the box number here and the full label that we need to remove here, or just a label we want to remove. And then, yeah, this hashing is not necessary anymore. So we go into the insert function. Here we will fetch the box. We will see if we can find the label in here, and if we do, we will replace the label with the value here. If we don't find the label, we will add it. The remove function is pretty much the same. We will look for the label, and if it starts with that label, we will just remove it. Nothing strange there. And then we have the calculate boxes. This is pretty much just go through the full list here. We will get out the box value. We'll go through the list of strings. We'll look at each position of the string and get also the second part of this operation, which is the number we want to multiply with. Parse that out as an integer times the box command position and the box value. And we will increment that to the value. So that was day 15. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you have another solution to this, leave that in the comment section down below. I read and watch and look at it all. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.